So continuation of mass spectrum and ionization energy questions. We discussed the first 7 in the last session. Question 8, a sample of element X contain only isotopes are shown. What is the relative atomic mass of element X? And we have to write to 3 decimal places. So the percentage of the isotope multiplied by its abundance, and then divided by the total sum of the abundance, which will be here 100. So this is mass is there and the percentage. So it is 68.00077 times 58, or here I can use the space. So 58 is there multiplied by 68.077 plus, like percentage, it is a percentage multiplied by mass, then or mass multiplied by percentage, same thing, 60 multiplied by 26.223, then 61 multiplied by 1.140, then 62 multiplied by 3.634, then 64 is there and multiplied by 0.926, and then the total divided by the sum of the abundance, the percentage abundance, that will be 100. The total will be divided by 100. So for question 8, when we substitute these values, we'll get, and 3 decimal places. So B and C cannot be an answer. Why? Because it's 3 significant figure, not 3 decimal places. Like after decimal, we should have 3 numbers. So it can be either A or D. So when we simplify, it will come out as option A, which is 58.760. How many orbitals are there in total in the first 3 quantum shells? So in this question, they're asking how many orbitals are there in total 3 quantum shells. So how to work out this? We have 1s, then we have 2s, 2p. Then this 2p is the subshell, but they're asking orbitals. Keep in mind, p is the subshell which consists of 3 orbitals: px, 2px, 2py, 2pz. So actually, the first shell contain only 1 orbital, that is s orbital. The second shell contain 2 subshells, which is s subshell and p subshell. S is only 1 orbital, but p is actually divided into 3, which is px, like, so it will be 2px, 2py, 2pz. Then for the third shell, it is 3s, then 3p, and then 3d. And p is divided into 3px will be there, 3py will be there, and 3pz. And d is divided into what? It will be 5dxy, dyz, dzx, like, and dx square minus y square and dz square. So how many total are there? The first shell contain only 1. The second shell contain 1, 2, 3, 4. The third shell contain 1, 2, 3, 4, 5, 6, 7, 8, and 9. So when we sum, what it will give? It will give 14. That's why D is the right answer, because they asked orbital. They did not ask subshell. They asked orbital. Orbital means like 2p is the subshell and P consists of three orbitals. One is Px, another one is Py, and the third one is Pz. And the maximum number of electrons in each orbital can be 2. Is it clear? This question 9.
Yes, sir.
Any
Yes.
doubts? Okay. Feel free to ask your doubt. Like if any question you're not able to understand, just let me know. So I will repeat that. You can use your mic or a chat, even it's okay, fine. You can use a chat if any question you want me to repeat. Another question, a mass spectrum and the ionization energy, which element is in P block and has atoms containing 2 unpaired electrons? So P block, lithium cannot be, lithium is S block element. It can be carbon, it can be fluorine, it cannot be titanium, which is a D block element. So we are left with 2 options. We are left with carbon and we are left with fluorine. Now, when we write the electronic configuration for carbon, it is 6. Atomic number carbon for carbon is 6 and fluorine it is 9. So when we write, it will be 1s2, 2s2, 2p2. So electron in a box model for carbon, this will be 1s, 2s, and 2p is having 3 orbital py, 2px, 2py, and 2pz. And this one is 2s, this one is 1s. So first shell it will have 2, second shell it will have 2, and the third shell it will have 2 are there, but first they will occupy singly. So you can clearly see there are 2 unpaired electrons. That's why option B is the right answer. Why not fluorine? So when we write for fluorine, we have to arrange 9 electrons. So how the 9 electrons will be arranged? It will be 1s2, 2s2, 2p, because 4 are there, so 2p5. Then if I make electron in a box model for fluorine, 1s, then 2s, and then 2p, x, y, and z. So 1s is having 2, 1 clockwise, anti-clockwise, clockwise. First they will occupy singly and then pair up. So you can see 1 unpaired electron is there in fluorine, where 2 unpaired electrons are there in carbon. That's why B is the right answer for this. Question 11, the first 5 ionization energy of the elements are given. So using the successive ionization energy of element, using those ionization energy, you can identify the group. How you can identify the group? If ionization energies are comparable, it means that like it just only double or approximately double or close to double, it means they're in the same shell, electrons are removed. But if there's a big jump, it means that electron is removed from another shell. So when we check this is first ionization, then second approximately 3 times, then approximately double, approximately like less than double, but approximately. But when you check 2,745 change to 11,000, this is a very big jump, a big difference. And due to this very big difference or jump, it means that 3 electrons belongs to the same last shell, and the 4th electron which you remove belongs to inner shell. So this element, it means it belongs to group 3. So which is the third group? Sodium is first, magnesium is second, aluminum is third, and silicon is fourth group element. So C is the right answer, that it is aluminum, as we remove 2 electrons from, as we remove that, like the first 3 ionization energies are comparable. When we remove the 4th electron, that is removed from the inner shell, because there's a big jump. Then this question is about the element chlorine. We have to give an electronic configuration of a chlorine atom in a ground state. Chlorine means ground state means like normal chlorine atom. Excited state means when it either electrons are in a higher level, we call that as excited state. So chlorine is having 17 electrons, so we have to arrange 17, 1s2, 2s2, 2p6, 3s2, 3p5. So 17 electrons. Write an equation for first ionization of a chlorine, including a state symbol. First ionization means energy needed to remove electron from neutral gaseous atom. So we have a chlorine atom in a gaseous state. We supply energy, we remove electron by supplying energy. So it will form a chlorine ion in a gaseous state, and there will be one electron. Explain the difference in the first ionization of a chlorine and bromine, 3 marks. So chlorine and bromine, basically they are asking what is the difference of ionization energy as we go down the group. So as we go down the group, the more shells are there, greater shielding effect is there. As a result, greater shielding effect, so less attraction toward between, or like smaller force between the electrons and the nucleus. So it will become easy to remove electron from an atom. So the points which you should mention here, one about chlorine and the bromine. So even though when you check, there is a greater nuclear charge for bromine, like bromine is having more electrons, more protons than chlorine. But the difference is electrons are far away from the nucleus. As a result, when electrons are far away from the nucleus, there's more inertial electron or a greater shielding effect. So the points which we can add here, bromine, more electron shells, greater shielding effect, so it will have a smaller ionization compared to chlorine. Is it clear? The question?
Yes, sir.
Yes.
Okay, and then chlorine occurs naturally as a diatomic molecule. We have to just draw a dot and cross diagram. So we have a chlorine atom, dot and cross. So chlorine atom, chlorine belongs to group 7, so it share 1. This chlorine share 1, other chlorine will also share 1. So unshared will be a 3 pairs or 6 electrons will be there. This is a dot and cross diagram for chlorine molecule. Then explain, chlorine is a gas at room temperature and pressure. Explain why chlorine is having a low boiling point. So when you compare the boiling point, one is, it is having, like example, it is a simple molecule. So it is having weak force between the molecules. A small amount of energy can break the molecules apart. So it is a simple molecular compound, simple molecular structure. And weak force between the molecules. So a small amount of energy can break the force. Then chlorine has 2 stable isotopes, 3:1, and we have to complete a mass spectrum for chlorine, a sample of a chlorine which is having expected molecular ion peaks. So remember, the ratio is 9, 6, and 1. That is one thing. Like one is 9 times, another one is 6 times, another one is 1 time. Chlorine 70 is 9 times. Chlorine 70 is 9 times. Chlorine molecule 72 is 6 times, and chlorine 74 is 1 time. And we already discussed the reason for that. Like when we take a simplest ratio, if chlorine 35 and 35 are there, that is 9 times as compared to chlorine molecule, which is 35 and 37. So that will be, this is 70, this will be 72. And chlorine molecule, which is 74, is only 1. So the relative abundance when you show, like in terms of percentage, it is 9, 6, and 1. You can represent this 9, 6, and 1 in terms of percentage as well. Or you can simply show like 90, 60, and 10, because the ratio will be 9, 6, and 1. So 70, this is 90, 72 is 60, and then 74 is 1. Then suggest why there could be a small peak at 36. Look, what we assume that we are removing only one electron, like mass to charge ratio. These peaks are m by z means mass to charge ratio. So if the mass is 72 and the charge is plus 2, so 72 divided by plus 2, then it will be plus 36, means we'll get a peak at 36 instead of 72. So why there might be a peak at 36? Because that shows that the charge of the chlorine molecule is plus 2, or the molecule of a chlorine 72, which is having a charge of plus 2, can give a peak at 36. Is it clear, this part?
Yes, sir.
Yes.
So these are some questions related to the topic. I have shared this file with you. So solve and submit on the due date.